Okay, good morning all. Thank you for joining us today for this webinar on fail-safe features. So the video will be available in the support section of our website in the coming days after this. You're more than welcome to ask questions throughout the presentation using the chat/message feature which you'll see in your control panel, and we'll go through these at the end of the presentation. Okay, we'll get started there now.
Hi, today we'll be doing an introduction to fail-safe features in Horner's all-in-one controllers. So let's take a look at our agenda for today's tutorial. We're going to talk about two specific fail-safe features, backup and restore and autoload. We're also going to talk about cloning, which is not directly a fail-safe feature, but it is related and very useful. As always, we will finish with a live questions and answers session. Fail-safe features are designed to keep machines running to avoid disruptive program loss and memory loss. The most common issues that machines run into in their life cycles are typically battery issues. Batteries have a limited capacity, limited life, and they can be affected by temperature. The most likely issue that a machine can face that a fail-safe can help with is battery issues. It can also help deal with memory corruption, but in 2020 this is a much rarer issue. The longer your equipment stays in the field, the more important your fail-safe becomes. This is because over time, the limited life batteries become more prone to fail, and because day by day, more time passes without anyone doing work on the machine. When time passes, we forget things. Documentations may change, so again, fail-safes are important. This is especially true years down the line in dealing with problems that can easily be recovered from if you had a fail-safe in place. The first one we're going to talk about is backup and restore, which is in reality the most important feature, as in the situation of a battery issue, it can save you entirely. This battery issue could come 7 to 10 years down the line, and who knows what could have happened between the time. The beauty of the backup and the restore feature is that it does not require a memory card. So what does backup and restore do? It copies some important information to a safe location in Flash. So when you perform a backup, it copies the checksum for the OCS application program, it copies all the variables and register values, and it copies all the OCS system settings. All the things set from the system menu, for example, VOD rate and RS-45 determinations, etc. It takes all that information and stores it away in a safe location in Flash, where it can be retrieved later if and when it's needed. It's enabled fully from the system menu, though there is also the option of fully utilizing system registers to enable the feature again. It's most commonly useful when battery issues appear in the future. It doesn't protect against flash corruption, although that is very rare. Next, I'm going to show you how to set this up on an XL4 as an example. Before you begin, you need to make sure that in general, the system is running as it's ready to deploy. You're going to set a bunch of parameters in the system menu on, perform a backup, and then you're ready to go. You can then deploy the machine, and if you ever have an issue in the future, you can deploy the recover in an elegant way if, for example, a battery failure occurs. In the case of one of our traditional controllers, such as the XLT or XLE, if you have a battery issue in the future, it can really save you, as it can keep your program from being erased and maintain a good set of register values that you can continue to run until you can replace your battery and get your calendar clock back. With rechargeable architecture, your program isn't lost if you lose a battery, for instance, although you do lose variables and registers, etc. So backup and restore definitely is still valuable. If you don't utilize backup and restore in traditional architecture, you'll lose your program, your variables will all reset to 0, and you will have a no user screens to display message on your unit. With the rechargeable architecture, the main difference is the system is going to convert to old registers, you're going to lose your clock, but you won't lose your program. Next, let's show you how to set up backup and restore. We want to start from a position where the program is running the correct system settings and with the variables all set to their correct values. So first, let's go to the system menu, go to failsafe, and start by enabling Autorun. Autorun means that if we ever have to recover using failsafe, we're going to recover and then going to enter run mode automatically. The next step here is to perform a backup, which we do here by selecting Backup and Restore Data. So what does a backup do? It takes a copy of the checksum for the current application program, plus a copy of all the current system settings, and a copy of the current values of all the variables and all the registers in the program, and store all that to a safe area or flash. Then, if we have a battery issue in the future, we can recover from it by loading in this known set of data. This may not be the latest data, but it will be a solid known set of data to work from, allowing the system to recover until the battery is replaced. Now we're ready in case there is a battery issue, so to test, I'm going to take out the battery to help demonstrate how to use backup and restore in case of a battery failure. I've also changed a few parameters since I started running the unit. So let's perform a power cycle with a bad or missing battery. Okay, so we're powering up and we should get a battery error. So self-test, battery voltage problem. However, we did recover. You'll notice that these parameters are not the same as they were when they were powered down, but they do match the values at the time of the backup. You can also see that the OK light is off, which is because we have a bad battery, but we are in run mode and we are operating. The other change that's occurred due to having no battery is that the calendar clock is not able to keep current time. So, if we look at time and date, we've gone back to the default time and date of the 1st of January 1996, and every time we power cycle, we're going to go back to that date. Okay, so no, it's not perfect, but the system is still running using a good set of values, and we have recovered. Now we can fix the battery, set the clock, and fully recover with some human intervention. Okay, so that was backup and restore, an important feature to keep the system running. The next failsafe feature we're going to talk about is Autoload. Autoload protects against issues in Flash. For example, flash corruption, which is rare, or accidental program deletion from human error, or commonly a failed or aborted download, where you start downloading a program to the OCS, it gets interrupted, and now there's no valid program running in the controller. Autoload does require a memory card. Memory cards are quite cheap these days and also give you additional functionality such as data logging, for instance. Autoload is invoked when the OCS powers up if there is no valid application running in the unit. In that scenario, Autoload will effectively look for Autoload PGM on the memory card. If it's there, it'll load it and it'll run. This feature can be enabled from the system menu, just like backup and restore, or from the system registers. The steps required for setup are extremely simple. There's a couple of parameters to turn on in the system menu, and then you're effectively done. We will show you how to do it through a demonstration in a small while. If Autoload is ran within traditional or battery-backed architecture, the result will be practically the same. So if the OCS powers up, and the battery is fine and the RAM is fine, but there is no valid program, it's going to look for autoload.pgm, load it and run. The counter clock and all variables should be fine after this process. So that's what happens if you have enabled Autoload. If you haven't enabled Autoload and your OCS powers up without an application program, it's just going to sit there and wait until somebody comes on site and takes care of it, which is obviously not desired. Okay, so let's go through the process of enabling and demonstrating Autoload. To set up Autoload, we first have to go to the system menu. Autoload does require a removable media card, which we have one here, but it appears to be empty. The next step is to go back to the failsafe menu and make sure that Autoload is enabled. So we'll set that to yes. And after we have the program load automatically, we're going to want to make it to run automatically. So we're going to enable Autorun as well. Okay, so now we've made sure that we have a memory card, and we've made sure that both Autorun and Autoload are both set to yes. If we ever load this program, we have to have a program to load, and that program has to be named autoload.pgm. We could create that file from Cscape using the export to removable memory feature, but the easiest thing to do is to go from the unit itself and perform a make a clone. So I've gone into the clone menu. I'm going to select make clone, and this process is going to create that autoload.pgm file that I need for Autoload to work properly. It will also create a clone.dat file, which won't be used for the purposes of Autoload. Now that we're set up properly, let's go and simulate that failed download. I'm going to go to Cscape, and I'm going to perform a download off screen in Cscape. So soon you should see the impact of it on the controller. So now I'm going to interrupt that download, which is simulating, for example, losing an internet connection. So now this unit does not have a valid program in it. The way we can recover from that is going to require a power cycle. So now that we've performed our power cycle, we have an error, corrupt user tables, and Autoload and Autorun are being initialized. So we've already fully recovered from it. If we go to the system menu, we can see that both OK and Run are both on. Okay, so that's how to set up backup and restore and Autoload. In my demonstrations, I show you how to set it up from the system menu, as that is most common. But you do have the ability to manipulate system registers to do a lot of these same functions. So with backup and restore, you can enable Autorun from ladder using a system bit. You can perform a backup using a system bit. And you can do a lot of these features from ladder as well, from the system menu. One of the advantages of the perform backup bit is that over time you can make newer backups, so if you ever lose your battery, you'll revert back to registers which are more recent. You could, if you wanted, to make a backup from ladder every day and it wouldn't wear out your flash. However, if you did it much more than that, it could impact the life cycle of your flash chips. Next, let's talk a little bit about cloning. Cloning is not necessarily a failsafe feature, although we saw that it is related as we used a clone so that Autoload could work. Cloning is a feature that allows system designers to replicate exactly the operational state of one of our all-in-one controllers to an identical unit. This only works going from one identical unit to another, for example from XL4 to XL4. A good use of a clone would be if you're, for example, in OEM, doing production, shipping units out every week, where you've got a golden sample on one of your machines. You would make a clone of the golden sample, then take that file set that has autoload.pgm and clone.dat on a memory card and put them in blank units. Load clone and basically replicate that same golden unit as you ship units out the door. So that's really valuable from a production standpoint. It can also be valuable if you have the clone file set, autoload.pgm and clone.dat. If you have it on a memory card and have to replace the controller for any reason, you can take the memory card out, put it in a new controller, and at least get back to the same point you were when the clone was created. If you do have security enabled, to protect your intellectual property, if you go to load a clone and there's a password in it, it's going to ask you for it. Once again, you can do cloning from system registers, although it is less common. There are system bits available for that function. So that's all for today's pre-recorded tutorial. Next, we're going to move on to some live questions and answers.
Okay, everybody, we're just going to go through a few questions there now. And can we create the Autoload file using Cscape? Yes. So we have an export removable media function in Cscape. You can get that through the File tab. So when we save our program there, it is saved as a PGM, and we just need to remember to save it as Autoload. And depending on the firmware in your unit, you may need to adjust the firmware version when saving this file, but that's fairly straightforward. What register data do we see? What register data will we get when the backup is done? So the register values are those taken at the time of the backup. Where is the backup stored? So it copies the battery backed RAM contents to the onboard flash. That is where it is stored. I see a question here about clones with the firmware. The firmware needs to be the same for the clone on units. So just watch out for that if you are cloning. Make sure it's the same firmware on both units being used. What happens with a PGM file on a different firmware version? So if you create it with a different version to what's in the unit, it won't let you upload that version. So when you put in your SD card back into the unit, that PGM won't load, you'll get an error. So that's just what you need to watch out for there with the firmware versions when creating the PGM. Does cloning require an SD card? Yes, it does. What registers are used for, or can we use registers to do the failsafe? Yes, I think that question came in just before that slide. So there was a slide on all the system registers that you can use to do the failsafe features through ladder. But I'll just give you some of them there now. So to perform the backup is system register 164.7. The autoload is 164.6. Autorun is 164.5. But this video will be available in the coming days, so you'll see that in the video again anyway. That appears to be it. Thank you all for joining us this morning, and have a good day. Thank you very much.